Hello, today we're doing the analysis of a combustion reaction containing oxygen. The problem we have today is a compound consists of only carbon, hydrogen, and oxygen. 8.272 grams of carbon dioxide and 4.515 grams of H2O are produced during complete combustion of 3.765 grams of the compound. A. What is the empirical formula of the compound? B. What is the molecular formula if the molar mass of the compound is 300.47 grams per mole? Alright, first for a combustion reaction, I like to go ahead and start setting up my combustion equation. And this is a combustion reaction of carbon, hydrogen, and oxygen. So therefore, I have my C, H, and O, and I label my variables or my subscripts on the side with an X, Y, and Z, considering I do not know them yet, plus oxygen yields carbon dioxide plus H2O. And I want moles of carbon, and I'm given 8.272 grams of carbon dioxide. And I am going to use carbon dioxide to find my moles of carbon due to the fact that there is only carbon and carbon dioxide on my product side. Therefore, I will only be using carbon dioxide to find the mass or moles of carbon. To further, there again is my mole map. We're going to go to the mass of carbon dioxide, to the moles of carbon dioxide, to the moles of carbon, and then therefore the grams of carbon. And yet again, we're looking for the moles of carbon, so we want to find moles, but grams is also going to come in later on. So to set that up, we have 8.272 grams of carbon dioxide, and then that is going to be, we're going to use our molecular weight, apologies. So we have 44.01 grams of carbon dioxide per mole of carbon dioxide, and then we're going to use our molar ratio of carbon to carbon dioxide to find the number of moles, which I like to label above, like you see, so I can both find the number of moles and the grams of the element of the compound I'm looking for. So as you can see, it's a 1-to-1 ratio, and I wrote my molar mass, or my number of moles, 0.1880. And then I go on to multiply it by the molecular weight of carbon to find the mass of carbon in my compound. And then I do the similar problem to the next. Again, I want the moles of H, and I'm given the 4.515 grams of H2O. And again, I'm only using H2O on my product side due to the fact that there is no hydrogen except for in the H2O. So I go on, and my molar map is going to be a mass of H2O to the moles of H2O, and then I'm going to go to the moles of H and the mass of H. And then it's going to look a little bit like this, the 4.515 grams of H2O, and then I have my molecular weight of H2O is 18.016 grams per 1 mole of H2O. And then again, I'm going to use my molar ratio to find the number of moles I have. So that is going to be 2 moles of hydrogen per 1 mole of H2O. And yet again, I have my number of moles labeled above my mole section, which will there come in handy later. And then I'm going to further and multiply it by the molar mass, or the molecular mass of hydrogen, to get my mass of hydrogen in the compound. Right. And from there, you might be confused because of our oxygen. We have oxygen in both H2O and CO2. But considering we have the mass of carbon, the mass of hydrogen, and the total mass of the compound, we can find the mass of oxygen. So therefore, we are going to use our simple addition and subtraction skills and take that 3.765 grams of the total compound minus the 2.257 grams of carbon minus the 0.5052 grams of hydrogen, and then that is going to yield us 1.0028 grams of oxygen. And therefore, we're going to move that oxygen into molar form as well. So we're going to find the number of moles in that 1.0028 grams of oxygen, and we're going to use our molecular mass, to find that, which is going to give you an answer of 0.06268. And this is going on to find our empirical formula now. Considering we look at the number of moles in each element, we have 0.6268, we have 0.512, and then we have 0.1810, or apologies, 0.1880. And we need to take a look at all these numbers and decide which is the smallest. Of course, we can look at it and easily identify this to be the smallest. So we are going to divide all of our moles by the smallest number of the element with the smallest number of moles, which is therefore going to give us 1 of oxygen, 3 of carbon, 8 of hydrogen, which is going to give us an empirical formula of C3H8O1, or just C3H8O. And this is to go on and find the molecular formula as well. You want to go ahead and find the compound mass of that C3H8O. And that is going to go on to be a 60.094 grams per mole. And you're going to find the molecular formula by using your empirical formula. So therefore, you have your total weight, and then you are going to divide that total weight of the compound, that 300.47, divided by that 60.94, which is going to give you exactly 5. And therefore, you use that 5 to multiply by all the subscripts in the empirical formula, which is therefore going to give you a molecular formula of C15H40O5. And that is an analysis of a combustion reaction containing oxygen.